Hello, everyone. Thank you again for joining us this evening. I'm Nina from Space for Impact. Today, we're introducing you to the Swiss Dataset, which includes data from the Swiss Data Cube and ancillary data from Swiss Topo and Meteo Swiss. Presenting will be Dr. Claudia Röösli, Head of National Point of Satellite Data at the Remote Sensing Laboratories at the University of Zurich, and Charlotte Poussin. She's a researcher and PhD candidate at the University of Geneva in environmental science. In this context of her PhD, Charlotte works with the Swiss Data Cube to measure and monitor the consequences of climate change in Switzerland using remote sensing data. Claudia, are you ready?
So I hope you can see my screen now. Also, welcome from my side. Good evening and welcome to a short introduction into what you will be able to do or try out with the satellite data during the CASSINI Hackathon, including a short introduction in satellite data and how to use them. So if you're already very well aware what you can do with satellite data, maybe you can lie back a little bit and just enjoy nice images. And otherwise, I hope it will be helpful for you for the hackathon as a baseline in order to deal with all these data sets we have for you for the challenges. So my name is Claudia Röösli. As Nina said, I will give you in the first part a short introduction in the satellite data, what we have and what you can do. Then afterwards, Charlotte will take over, introduce you more into the data sets that are available for the CASSINI Hackathon. And at the end, I'll take over again and give you a hands-on demonstration, how you can have a look at the data, how you can use the data in an easy way, and also to show you the auxiliary data sets that we have available from other providers than just satellites. With that, we're going to start into the introduction in satellite data. So the answers I would like to give you an insight today that you know what you're dealing with is mainly to explain you what is Earth observation and remote sensing, what types of satellites orbit the Earth, then of course what we can learn from satellite data, and in particular important for you of course is how you can access the data and use this satellite data in different ways for your challenges and for your innovative ideas. So first, what you can see here is a very nice image. Yes, it's not from Switzerland, I have to admit, but still it's a delta in a ocean. So what you can see is a false color image, and it's coming from far away. And with this, I can tell you what is remote sensing. The definition is actually the detection and monitoring of physical characteristics of an area. So in the background, you see, or you can imagine that there is some water, there are different types of surfaces and reflectance of the Earth surface in this area. So what we observe is either emitted or reflected radiation coming or going to the Earth's surface, and most important regarding remote sensing, we do not touch. That means we are usually from far away, in our case, of course, from satellites. And the difference to Earth observation itself is Earth observation is a general term that we do remote sensing from space. And of course, we do not touch as we are far above the Earth's surface. If you have followed the introduction yesterday, you might have already seen this slide. So we are in this CASSINI Copernicus Hackathon. That means we are mainly dealing with Sentinel data. Sentinel data means at the moment projected there are 6 different satellites. You will see there are 7 on this slide. I'll explain you in a second what that means. So we have 6 different types of satellites that give us different type of data, and I'll give you a brief introduction in what all this satellite data can bring to you. The first ones are the satellite data we will have for the hackathon, the CASSINI Hackathon. However, we will not have data from all the satellites available, as we also want to give you some potential for future hackathons in the CASSINI project. So the first and one of the most common, known and easiest to understand, let's say Sentinel-2, It's up and running, consists of 2 different satellites, and is usually used for all different things, but has a high strong focus for anything that is dealing with land and biosphere. So what it is called a multispectral optical satellite. That means it includes the visible bands, meaning the red, green, and blue bands that you know from your cell phone, but also additional bands, and I'll show you some example afterwards. What you can see here is an example from an image. You might have heard from the natural hazard that we had in 2017, I think, from Pitch Cengolo, where we had a lot of a huge disaster in Bondo from a rockfall. So this is a data set you will be able to access for the Cassini Hackathon. The second satellite I want to show you is Sentinel-5P. 5P means precursor. That's why we have 7 satellites on the image. Sentinel-5 is not built up and running yet, and that's why, in order to bridge between an old satellite that is also not up and running and the new generation from Sentinel-5, they launched satellite 5P. That is mainly focusing on atmosphere, so it measures ozone, methane, aerosols, air pollution, and others. And actually, it got very much into focus. What you see on the image to the left, there is an image before COVID and during COVID lockdown. So you see the air pollution, for instance, around Paris or Milan and Turin, which is in dark red, was very high before COVID, and then COVID lockdown came, and you see the air pollution here represented with the NO2 values measured decreased a lot. You will be able to access this data also for your challenges if you like. Then the third satellite I'm going to present here is Sentinel-3. Sentinel-3 is also a multispectral optical satellite with a different resolution. You can use it for also many different applications. Here, what I show you is a hurricane, and what it measures is actually the cloud temperature. So the clouds that are built during hurricane can be very well imaged by Sentinel-3, meaning if you have different layers, you have different temperature, and then you can really see inside the eyes of the hurricanes, as an example. Then we have Sentinel-1, which is also a bit a special one. It's a so-called synthetic aperture radar. So it's not making images like we see from our human eyes, but it's sending out some energy coming back. And one of when it came into focus was, for instance, there was an ice shelf breakoff in Antarctica on the 12th of July 2017, where this image was taken. And what you have to bear in mind, 12th of July in 2017, it's dark night in Antarctica. So that means this satellite can look through clouds and even doesn't need any light from the sun. That's why it's very powerful also to image, for instance, the poles during the season when there is no light. Then the last one in the row that we'll explain is Sentinel-6, which has been launched just recently, last November. It's not up and operational, but this image is coming from an older satellite, the same type, JSON-2, which mainly images the sea surface with an altimeter. So it's measuring the distance between the satellite and the sea surface, like with a signal. And here, what you can see in the image is an El Niño, La Niña event already in 2015, when there was a difference in sea surface height. Of course, this is the focus of this mission, is to monitor the sea level rise that is currently ongoing due to the climate change. So with this brief overview, I want to go dig into a bit more. You see, there are many different types of satellites available, but for you, most important is how do you select the data source? And for this, you need to know first what do you want to see. So depending on your needs, you will then select the data source. Questions you need to think of is, what process do you want to see? That means mainly you need to choose the sensor type and the spectral resolution. I will explain you in a second what I mean with spectral resolution. Then what detail you want to see, meaning spatial resolution, and then how often you want to observe, meaning what if it's an ongoing process, is it once every whatever time? So you need to think about temporal resolution. And each of the satellites that are orbiting around the Earth has different characteristics and so a different use for you. So maybe first, we have two types of satellites available. So first, we have passive satellites. So they measure the sunlight coming from the Earth's surface. That means they need daylight. And here in the red circle, you see it's Sentinel-2, Sentinel-5P, and Landsat-8. This will be the datasets we have available for the Cassini Hackathon. This can be compared with like your cell phone camera. It's just taking a picture from the satellite of the Earth's surface. On the other side, we have these active sensors. They emit energy that comes back, and they measure how much coming back, like the system you use to park your car. It's inside a parking lot. We will not have, for this Cassini Hackathon, this dataset available. So then, this is again the example showing the Bondo rockfall. So you can see here, and you have to be very careful in the area here. What I will show you in a second is a false color image. So I'll take other bands, not just the RGB, that you can see a bit more what I mean. And I'll show you a time series of different images. That means images that were taken from Sentinel-2 before and after the rockfall. So pay attention. These two areas are the areas of interest. So now it's going through. And now you saw here that there's this huge landslide coming down. And if you look at the time of overflight, where we had images available, it's around every 5 days. So with Sentinel-2, we get one image every 5 days for Switzerland. And here you can also see for Sentinel-2, which is an optical satellite, we need to have good weather. So as soon as you have cloud cover, like the last image, you don't see anything anymore, which is one of the major drawbacks of this technology. So pay attention on cloud cover, which will certainly be a topic of your work afterwards. And here you see very well how all the mud arrived in Bondo after the event. On the other side, here's a comparison of the spatial resolution. So you see MODIS, this is quite an old satellite that is already orbiting a long time in the Earth. So we have 250 meters resolution. Then we have Landsat, which has a 30-meter resolution, which will be available for the Cassini Hackathon. We have a 10-meter resolution. And here you can already see, with 10 meters, you see a lot of details. With 30 meters, it's not that many details, but still quite good. And then, of course, we have commercial satellites here. We will not using commercial satellites, as this usually is either expensive or they do not have that regular observations available like this. So the main one we are using, of course, is Sentinel-2 and Landsat-8. Here you can see the spectral resolution. What do I mean with the spectral resolution is, on the top one here, you have the different bands that are available where Sentinel-2 can measure. So on the x-axis, you have the wavelengths. And in gray, you have where light can go through the atmosphere to a satellite. And then on the here on the y-axis, you have just here is the Sentinel-2 image, here is Landsat-8, and here is Landsat-7, but Landsat-7 will not touch within the Cassini Hackathon. So what you see here is you have around 12 bands where the satellite is sensitive and can observe the surface. So we have VIS, which is the visible spectrum. That means this is red, green, blue. Then we have the near infrared. Then we have the sphere 1 and sphere 2. And maybe already to say Landsat has the same bands, so you can see it in a vertical manner. However, why we are also using Landsat 8 for this challenge and for this Cassini Hackathon is actually there is an additional thermal band. So everything that is about heat and coldness, of course, is in the thermal band. That's why we added also Landsat 8 images for the challenges that deal with the heat within the hackathon. So what I want you to know, I will show you an example what it means, the spectral resolution and what you can do with that. So I want you to focus on the band 2, 3, 4, and 8, as well as the bands 11 and 12. What you can see here is an image using red, green, blue channels, as you know it from a cell phone or from a normal photo camera, from the Vesuve in Italy, from Sentinel-2, from 12th of July 2017. And Vesuve is covered here underneath of some smoke. What happens if I change the channels? Suddenly the smoke disappears. And if in this case I use the sphere 2, 1 and the near infrared as a false color image combined, you certainly can see, oh, here is this is the signature that you can see from the lava that is going out from Vesuve. Not from the lava, I'm sorry, from the burning forest. Of course, Vesuve doesn't have lava, luckily. So it's not lava, but it's fire. So there was a huge forest fire around, and this is very difficult to observe from above if you're just using red, green, blue. But as soon as you go into other signatures, the clouds or the fog more or less disappears. So depending on what you want to see, you choose different bands with different characteristics. So in order to conclude, I hope you can now better understand which questions you would need to answer in order to choose the data sets of your interest. And with that, I'll give over to Charlotte, who will give you a short introduction on the satellite data that we have available for the hackathon and give you also some nice examples what you can do with the data.
So hi everybody, I am Charlotte from the Swiss DataCube team, and this morning I will give you some explanation about the data from the SDC. So in the SDC, the data are analysis 3D data, meaning that satellite data that have been processed to a minimum set of requirements and organized into a form that allows immediate analysis with a minimum of additional user effort and interoperability both through time and with other data sets. So as you can see in the images, these specifications save times, effort, and minimize the cost of pre-processing data. So as you can see in the figures, the requirement concern parameters such as radiometric and geometric calibration, atmospheric correction, and metadata descriptions. And in optical imagery, such as Landsat and Sentinel-2, as said Claudia, the hard level corresponds to surface reflectance products. So currently, data providers of Landsat data and Sentinel-2 data are not yet commonly generating in hard products, but deliver top of atmosphere reflectance named L1C. So to become surface reflectance named L2A, we use the live monitoring of Earth surface framework to generate Landsat 8 and Sentinel-2 hard data stored in the SDC. So for the hackathon, you will use collection 1, level 2 surface reflectance, and collection 1 sends our data with the highest available data quality, and considered suitable for time series analysis. So to see if there is a change over time. And level 2 corresponds to a surface reflectance, and these data are corrected for atmospheric perturbations, enabling direct comparison between multiple image and dates. So the SDC holds analysis with the Earth observation satellite data since '84 for the entire Switzerland. This archive update on a daily basis contains at this time more than 12,000 cents, so it's a lot. And for the hackathon, you have the opportunity to work with Landsat 8 surface reflectance data covering the entire Swiss territory. So as Claudia said during her presentation, Landsat 8 are a sun-synchronous satellite completing one Earth orbit every 99 minutes. So Landsat has a 16-day repeat cycle. So they are essentially designed for land applications such as Earth surface resources, land surface, environmental monitoring, agriculture and forestry, disaster monitoring, and assessment, ice and snow cover. Landsat 8 was launched in 2013, and the mission is expected to continue until 2023. A new generation of sensors were carried on Landsat 8 is the operational land imager and thermal infrared sensor. So to cover the whole Swiss of the Swiss territory, it requires 8 Landsat sensors. And you can see in the first images. And to cover the entire territory, Landsat 8 takes 9 days, as you can see in the animations. So currently, the number of ingested Landsat sensors correspond to 1,030 images for Landsat 8 in the SDC. Landsat 8 possesses a spatial resolution of 30 meters for most of its bands. And the spatial resolution is a measure of the smallest object that can be resolved by the sensor. So we have a good resolution to see some details. Landsat 8 possesses 11 bands, and in the SDC we provide only the visible band, the near and the shortwave infrared bands. And depending on what you want to study, we can combine the band and create index such as the NDVI to see the vegetation, for example. And the coordinates reference systems that we use in the SDC is the EPSG 4326, and its units are degrees of latitude and longitude, and the formats are net CDF. So a pixel quality assurance called Pixel QA in the Swiss Data Cube is provided with all Landsat surface reflectance. And it's available in the Data Cube. So the band is in unsigned 16-bit format. Values are bit packet and provide information pertaining to a pixel condition of field, clear, water, cloud, shadow, snow, cloud confidence, and cirrus cloud. And you can use this band to create some cloud mass, for example, as you can see in the image. It's very useful if you want to create some image without cloud or without snow or whatever you want to show. So during the hackathon, you will also use the Sentinel-2 satellite from the Swiss Data Cube. So the Sentinel-2 is a constellation of 2 sun-synchronous satellites operated by ESA, respectively from 2015 to 2022 is the Sentinel-2A, and 2017 to 2024 is the Sentinel-2B, and they work together. So this satellite supports land monitoring related service, including generation of generic land cover map, also risk map and fast image for disaster relief, generation of leaf coverage, leaf chlorophyll content, and leaf water content. So it's very useful to work on the vegetation also. And both satellites carry the multispectral instrument, and this will be completed and replaced by Sentinel-2 C and D in 2021. The temporal resolution for Sentinel-2 is 5 days, so it's much better than Landsat 8. when we use Sentinel-2A and 2B in tandem. And Sentinel-2B, so to cover the whole of Switzerland, it required 12 Landsat SEN, and to cover the entire territory, Sentinel-2 takes 4 days. Currently, the number of Sentinel-2 ingested tiles correspond to less than 7,000 images for a total volume of 3 to 6 terabytes covering the years from 2015 up to the present days. So it's a lot of images. And the spatial resolution of Sentinel-2 vary from 10 to 60 meters, depending on the bands. But in the Swiss data cube, we have only bands at 10-meter resolution. We resample every band at 10-meter resolution. So it's a very good way. As you can see in the image, this is the Glacier du Rhône, and we can see much more detail with Sentinel-2 than when we use Landsat 8. So in the Swiss data cube, all bands of Sentinel-2 are pre-processed and ingested except the band 10 that is only used for atmospheric correction and consequently not relevant for user. So it is important to mention that topographic correction is not applied as it creates strong artifacts. And all bands are resampled to 10 meters and align to Landsat data. So we can use the both satellites in the same data set, and they are perfectly in the same place. This means that one 30-meter Landsat pixel covers exactly 9 10-meter Sentinel-2 pixel without modification of data. So that is very useful when we want to cover a part of Switzerland and to see how the natural phenomena change over time, and we can have a lot of data in 1 year, for example. This is an important aspect to consider, allowing users to benefit from both satellites, both sensors, and to develop time series analysis to use multi-center data in a consistent way. As Landsat data, Sentinel-2 has also a pixel quality band named SLC with 12 classes, as I described in the presentations. So it helps identifying pixels that are saturated or defective, as well as cloud or cloud shadow or snow and vegetation, and they may affect the quality of the image. So you can see in the example that we have one simple RGB image, and then we apply the mask, and we have an image classification with all the category. So here we can find some example and how we can use Landsat data to monitor glacier change over time. For example, here is the Glacier du Rhône, and we can see the evolutions, and it's a simple false color composite. We also can use some algorithms to apply in the images. Here we can see a snow cover algorithm. We can observe the snow cover trend over the time, and over Switzerland we can observe a decrease of the permanent snow area and an increase of the rare snow area. So you are not, it's not obligatory to focus on snow, but you can focus also on vegetation. That's we do it. Here we use the normalized different water index, reflecting the moisture content in the plant and soil. And we apply this in all images available between the 80s to now. And we compare with some reference period, and we can estimate the evolution of the NDW over year by pixel and also create some anomaly. Here we have the mean annual anomaly for the year 2003 compared to the reference period, and we can observe the impact of the heat wave that we observed in 2003 on the vegetations. Okay, and that's it for me. So good luck for the hackathon, and enjoy the to play with Earth observation data.
Thank you, Charlotte, for this nice presentation and the overview on what one can do with such nice data. When you stop sharing, I'm gonna start sharing my slides again. Voila. So now we are already at the third part. I will give you a hands-on demonstration afterwards in the auxiliary datasets and also how you can have a look at the datasets. As a brief overview, so on one side, as you heard already, many times we'll have the Sentinel-2 time series available. That will be already cut into the areas of interest. I will introduce you the areas of interest that we have chosen for your challenges in a minute. However, we will have the time series from 2017 to 2021. For this satellite, we will have the same time covered also for Landsat 8, and also when available for this Sentinel-5P products, level 3. That means they're a bit more interpreted than the one for Sentinel-2 and Landsat 8. Regarding the auxiliary data, meaning we also we have a lot of different data sets available in Switzerland for free. So we will also provide you with a digital terrain model. So you will see like the surface, how it's going, where it's steep, where it's not steep. You will be able to use it for your analysis as well, if you like. We will provide you the Swiss Alti 3D called. You can also find a lot of information online, what it means, and it's from Swiss Topo and freely available now since 2021, I think. On the other side, we have some vector data sets. That means vector data sets means that you have the particular, for instance, path as a line object, not as an image, which covers the entire area, but as a single object. I will show you afterwards also what it means in detail. Here we are based on the Swiss TLM 3D, also by Swiss Topo, freely available now. We already extracted for you the hiking path and some public transportation network and stations. I'll show you it afterwards in a minute. However, there's a lot more available there as well. And I'll show you, in case you're already a pro or you have something in particular in mind, how you can access also all the other data sets for your needs. Then as a third type of data, we also provide you with the time series of the temperature or the weather stations. So in our areas of interest in Sio, we have a weather station, and also in Zurich. So you get, for instance, the temperature, the precipitation during the last whatever years that you could use for your projects. What I will do, I will now switch afterwards first into showing you, to give you a bit an overview of what you can do with the satellite data that you can browse around without having to deal with the images itself. We use for this the EO browser, which is very helpful to just to give you an overview, what data set is available, when do you have a nice image, what can you see, what cannot be seen. On the other side, I will also show you online. Most of you might already know the MapGeo admin portal, but you can very well see all the products as well that we then afterwards use by ourselves. I will then also show you on the webpage of Meteo Suisse what you have in terms of precipitation and temperature data sets for our areas of interest, that you can get a quick overview on what is available and maybe also ideas how you can use it. And then as a fourth step, I will show you on QGIS, so a geographical information system, how you can display and even analyze to a certain extent the data sets available. This will be also available on the Curidius, the platform where you're going to work. On the other side, if you're a pro already in coding and stuff, of course, you can do everything in languages like Python or R. There's a lot of packages available, but I will not go into details as this is a bit less nice to show. So QGIS is an interface where you can really deal that we are a bit used to it and not coding from scratch. Okay, with that, I'm gonna move to the EO browser portal. So what you can see here, it's easily available online. Everyone can click, can get the data like here. What you see, what you find first, you have to search for your area of interest. So I'm here already zoomed in into the Sion region that you can see here. I already have chosen, I want to look at Sentinel-2 images. There is many different options already here. We're just looking at the level 2 data, which is the most nice one, in a time range from May to June this year. And I'm going to search. And here you can see we have already possibilities of our flights. And I'll have a look, for instance, at this one where we had not that many clouds. This is loading now, just the visual band. So it's RGB that you can see here. It's a true color band. It's the 432, which is the corresponding bands for satellite. And you can already see it's partly snow covers, partly cloud covers, and you can zoom in, have a look. Okay, that's the data. That's how it looked like on the 29th of May. When you then want to look at other images, you can always see when you had an overflight and an image. So for instance, 24th, it's another image. There was a lot of cloud cover, so this one couldn't be used for your analysis, except if you want to know if it was cloud covered, of course. So we go back to the 29th, and I can also already show you what is available here just to play around. So a very interesting combination of bands is this sphere, which consists of different bands, as I showed you before. And what you can see here, it's a false color image already. And if I zoom out a bit, it's loading, of course. Here you see now a difference between green, which mostly is vegetation. Then you see this white stuff, which are clouds. And now you can separate it with the snow. So blue is the snow cover, and here you have some shadows from the clouds. So with this combination, for instance, you can already very nice see the differences. If you zoom in as well, it's loading still. You have also the urban areas coming with another color. On the other side, you also have, for instance, NDVI, which also was shown by Charlotte, which is a combination, what you can see here, between the near infrared band 8, and the band 4, which is the red one. So here you see again, the white ones are the either clouds and urban areas. And then you see like forest, everything that is very dark green means a lot of vegetation activity. This could be, for instance, used for your analysis. And then you have many, many different possibilities as well. Just play around the way you want. Now I changed the portal. You might know this one already. So when you start, you will see it here. So now we move to Zurich area. This is the pixel map of a Swiss topo. If you zoom in, you get another resolution, another type of the map. And what you can see, for instance, what we provide you as a data set are the hiking trails. So here, these yellow lines means this is the network of hiking trails. On the other side, you have also the bus stops, for instance, or the public transportation stops that will be available for the challenge. If you're already very well aware of the portal, so you can also switch, for instance, to orthophotos, which is not Sentinel images. This is the orthophotos flown by SwissTop, which has a higher resolution, but just once every 3 years flown. So in comparison to every 5 days for Sentinel, but with 10-meter resolution, this is something like some centimeters resolution, but just only every 3 years. If you're interested afterwards, or you know it already very well, you have many, many, many different layers available. So you can do whatever you want, you can have here. I will also show you another detail on the hiking path. If we zoom to Sion, and here what you can see, you have the yellow ones, and then you have the red ones, and then you have the blue ones. So you have the different types of hiking paths that is used, the system that is used in Switzerland. So you have the easy one, yellow, the red one, the more difficult ones, and the blue ones, the high mountain ones. I'll tell you that because I will show it to you afterwards how we deal with this in the data set itself. This already is just, there are many data sets available. As I said, this is just a hint where you can get the documentation on what is available and how you have to deal with it. This is the link we will also provide you. It's the Objekt Catalog Swiss TLM 3D. To be said, the Swiss Topo data set is in German. I'll show you that later. We have a description in German and in French, so that should cover more or less the languages we have in Switzerland, but it's not in English. So you need to be able to deal with that. On the other side here, this is the last data set. So we will have the time series of the weather station. So this one is the Sion weather station, what you can see down here. So we will have hourly values, daily values, monthly values. For instance, in this case, it's precipitation, so rainfall or snow, over the last years, over the last month, over the last day, whatever. You can also, as well, for instance, change to temperature. So we have the same. Currently, it's 22 degrees. Then you have the yearly value that you can use for your analysis, or any monthly values, whatever you're interested in. And what you can see also up here, so we have then the different possibilities. On one side for Sion, and on the other side, there is Zurich-Fluntern, which is the second one up here. Oh, no, that's Ram. Sorry for this, missed the lake. Here we have Zurich-Fluntern, which is the other weather station that we have available for the hackathon. Okay, so with that, we dig into even deeper into the data sets and we go to QGIS. I changed to QGIS. Voila. And what you see here is now finally the areas of interest. So you have the area of interest here in the green square for Sion, and up here, oh, that was not good, up here for Zurich area. Up here. You will get all the data sets that we mentioned already cut to this area of interest. That means you get the time series for Sentinel-2 and the time series for Landsat 8 already for this area of interest with the different bands that we mentioned. So for each of those, you have the 12 or 14 bands, depending on the satellite. And however, the Sentinel 5P we will give you for entire Switzerland, as they are only, or for a smaller region, for a larger region of interest, as the resolution there is 7 by 7 kilometers. Also because atmosphere and air is like moving a lot around, so it's not useful just one pixel and one value. So that doesn't mean much. So now I'm gonna show you first what we have available for Zurich area. I mean, you have both on both areas, but I show it to you first in Zurich. So when you load the DTM, so the digital terrain model, it looks like this. That means there is one layer and each of these points corresponds to a height. And now it's displayed by black and white. So you have higher areas and lower areas just with a color code like this. To get a better idea how this looks like, I can go into the options of this layer and then show it as a hillshade. Hillshade is the normal way how you display DTMs. If I do this, certainly we see stuff. So here is Zurich, the lake, which is flat, of course. Then you have the Uetliberg here, and then you have, for instance, Leghorn Forest up here. So with that, you can then do whatever you want. So you can do even analysis like exposition, where is north slope, where is the south slope, or you can do like slope in general. So where is it very steep? I mean, you see here it's very steep, and then here is flat, and all this analysis can be done also within the GIS system. So here, the next layer I will add that you will have available will be the Zurich hiking path. So what you can see here now, before we had like this spatial distributed layers of the DTM, or in the background, you see the Sentinel-2 image. And now you see lines. That means there are single objects that can be used for your analysis, and that's why it's called a vector data. So if I click on one of these, now we have the TRF. We click on one piece here, then you have all the information available on this side. What is the characteristics of this single piece of hiking path with all this information? So for all these little lines, you have all this information available. And this is exactly the point where we go into play. For instance, here you have Wanderwege, so it's a Wanderweg. Of course, Wanderweg means hiking path, and here you see the entire data set is in German, but you will have also the explanation and translation into French as well available for your work. Otherwise, you just need to use Leo or TBEL for translation, of course. On top of this layer, I'll add another one, which is the public transportation stops. So here, each of these dots corresponds to, now I didn't get one, corresponds to one stop. Here, for instance, it's Haltestelle Bus, which means it's a bus stop. And then you have other possibilities. For instance, here, it's a stop for a boat, for the boat on Lake Zurich. So this can then also be used for your analysis. And then you have this different type of information that can also be used to select a certain type of these points. And now here again, as I said, it's again a vector data set. That means there are just several points that are geolocated with different information. Here you have even the name of the bus stop. In order to show you a bit more details, I'll zoom into Sion. And here it's the same type, but what I have done already is actually I have selected a certain type of hiking path. So what I've done is, for instance, here, if you see this is a Wanderweg, it's a normal one, it's in red. If I click on one of these yellow ones, you can see Wanderweg is a Bergwanderweg. So it's a more difficult one. It's the one that I showed you before in the web application that is normally red. And it's also like signalized up in the mountains with red, white, red, white, red, white, of course. And this is something I can show you how you're going to do this quickly, that you know how you can select. So you go into the attribute table, and this is actually exactly the advantage of having such a rich data set inside the GIS system, I'm sorry, that you have all this information and then you can select whatever you want. So for instance, as a very, very simple question, I can say, I want to have the Wanderwege is, what did we have? Berg, let's say, only the normal Wanderweg. Like this. I select the feature and you can see what happens in the background. Nothing. Oh, sorry. I have to start over again. Wanderweg is Wanderweg in this case. So if I select the feature you see in the background, it becomes yellow. So they are selected now. And if I demonstrate again, the other one is the Berg Wanderweg. And then there is another sub amount of paths that are selected. And with that, then you can either cut it, use it, do it whatever you want, use it for other applications within the GIS system. So there you can really do with all this, with characteristics of these data sets. Just to briefly make the connection to what I showed you before. In this object catalog, you have all these details specified. So you have all the different data sets available. And if we search for Wanderwege, I'll zoom in a bit. Here you see we have the main group Wanderwege, and then we have Wanderweg, Bergwanderweg, Alpine Wanderweg, or anything else. So I extracted you the first 3 already in this data set. And here you can find any other data sets. So if you, I can also show you all the other data sets that are available is down here. So you have all these data sets available from Swiss Topo, where you have tons of information. If the hiking path and the public transportation doesn't is not enough for you and your other ideas. And as a last feature, I would also like to show you what I've done here with this Sentinel background image. I added, you have everything that you see, you have also available through the internet. So you can add this so-called WMS, WMTS layers, which means you have the access directly from the internet. So for instance, I have the Sentinel images as background. So I connect to this server that I pre-installed. I connect, and here you can see all the data sets that I can load just like this as a background. And in this case, I loaded the Sentinel-2 cloud-free layer from 2020, which is provided by someone that you can use. On the other side, this can also be used, for instance, for all the Swiss data sets. And here you can see all the different data sets you have available from the VBS, for instance. And here the Swiss Topo data sets, for instance, is like huge. So there's everything online, and then you can also have a look there and just load it. For instance, if I take even Swiss image, which is the Swiss, the image of Switzerland, I add it easily, and then I have it here. So if you look at this, I just loaded it. This is the Swiss image from Switzerland, loaded like this. I can turn it on, turn it off, that you see the difference. And here we have the difference in the background is the entire Sentinel image from the world. So with that, there is a many data sets available. So you can really play around, have a look, inspire yourself on all this very rich data sets we have in Switzerland and use it for your work. Everything is free and open. So be it the Sentinel, the Landsat, or all the Swiss data, Swiss Topo data, and also the Meteo data that I mentioned. And you can be creative, innovative, whatever you want. And with that, I gave you a lot, or we both, Gerald and me, we gave you a lot of inputs, interesting ideas about the data sets, what you could do. So now have a look already maybe on the web pages that you can play around to get a feeling what it means, these data sets. And then maybe for the hackathon, you can either use QGIS the way I proposed it, or even go into programming languages as whatever you wish. So this is many different tutorials online. If you have already an idea now, maybe you can even try it out and be inspired and be innovative. With that, I wish you good luck with all these data sets and also with the hackathon, and we will see each other anyway. I'll be also present during the hackathon for any ideas, any questions, your ideas. And for now, if you have questions, you can already send them, and then we will also give you answers already now. With that, thanks a lot for your attention. Have a nice evening and see you soon.
So thank you, Claudia, for this inspiring demo and inspiring talk from before. Thank you, Charlotte, as well. As Claudia mentioned, if you have any questions for Claudia or Charlotte, you can ask them directly on Discord. And we see you later at 7 for the workshop on cybersecurity. See you soon.